We're back here again. Sympathetic motor outputs, efferent motor outputs. Efferent means motor, right? And so the sympathetic division, cardioacceleratory center is going to ultimately contact the SA and AV node to increase heart rate. However, it also is going to, the same neurons are going to contact the myocardium. Why do we care about this? Well, in addition to altering heart rate, the sympathetic innervation can also alter contractility. Increase, let's just be specific. So in addition to changing heart rate, we are going to increase stroke volume. And this is through the same receptors, right? Norepinephrine, epinephrine, is we're talking about the adrenal medulla hormone, binding to beta receptors. This is going to be a positive inotrope. It's an inotropic effect, is related to contractility. How does this work? How does the sympathetic nervous system increase contractility of the heart rate, of the heart? You know how contractility works. We did this last week. Remember this idea of calcium binding to troponin to increase the initiation of thick and thin filaments. So what's going to happen is what we need you to get is increased calcium inside the cell so that we have increased initiation of cross-bridge formation and increased contractility, contraction. So we're going to have a cell here. This would be a cardiac muscle cell, right? And what's happening, we've got norepinephrine binding due to sympathetic innervation. This is the sympathetic nervous system, could also be from the bloodstream. Norepinephrine is going to bind to a beta receptor and activate a G protein. G protein activates adenylyl cyclase, activates CAMP, activates other proteins that are ultimately going to cause the opening of calcium channels. So phosphorylation activates proteins, actually can turn them off as well, but it's going to basically open up channels in the sarcoplasmic reticulum and the plasma membrane due to CAMP activation, that second messenger. What is calcium going to do? It's going to bind, it's going to be released and then bind to troponin. So contraction is initiated more cross bridges in more myocytes more often is going to increase the force of contraction. So although a single muscle fiber in the heart cannot be additive, contraction is still graded. So one fiber can still generate different levels of force. That's what we're seeing here. That depends on the amount of calcium in the cytoplasm, which we graphed that last week. Remember, I did a graph for you of calcium concentration and contractile force of the cardiac muscle. So this is the mechanism by which norepinephrine increases the force of contraction. Where we are here is right here. So with this whole diagram of things that affect cardiac output, we've done this, right? Increase or decrease due to the changing the rate of depolarization, that slope. Right now, we just talked about this, how sympathetic innervation and epinephrine from the adrenal medulla, this is from our nervous system, increases contractility, all about calcium. That's what we've just done.